A meniscus is the curved surface of a liquid in a container, like a test tube or a pipette, caused by the adhesive forces between the liquid and the surface of the container. It occurs because molecules of the liquid are attached to the container's walls, causing the liquid to either climb up or dip down, depending on the liquid's properties and the material of the container. When reading the volume of a liquid in a container, you always read from the bottom of the meniscus to get an accurate measurement. This is because the curvature of the meniscus can make it appear that the liquid is higher or lower than it actually is. When reading the meniscus with a pipette, first you fill the pipette with the liquid until it reaches a level above the desired mark, then hold the pipette vertically and wait for the liquid to settle, and lastly look at the bottom of the meniscus to determine the exact volume at eye level. A stock solution is a concentrated solution that contains a known high concentration of solute. It is typically used as a starting point for preparing less concentrated solutions by diluting it with a solvent. A dilution refers to the process of reducing the concentration of a solution, typically by adding solvent to the stock solution. We use the equation C1 times V1 equals C2 times V2, where C1 equals the initial concentration of the stock solution, V1 equals the volume of the stock solution used, C2 equals final concentration of the diluted solution, and V2 equals final volume of the diluted solution. The dilution equation expresses the relationship between the stock solution and the final diluted solution. C1 and V1 determine how much solute is initially present. C2 and V2 describe the desired outcome of the dilution process. The equation ensures that the amount of solute before and after dilution remains constant. This is why C1 V1 equals C2 V2, reflecting that the amount of solute in the stock solution will be the same as in the final diluted solution. A stock solution is prepared by dissolving a small quantity of copper 2 sulfate pentahydrate in a small amount of water in a small beaker. Once all of the salt was dissolved, we slowly added concentrated aqueous ammonia until the solution was a clear, dark blue color. Add an additional 10 drops of ammonia and then fill the flask to the mark with water. Transfer the stock solution from the volumetric flask to a clean, dry, small beaker. To prepare the first dilution, transfer a small portion of the stock solution to the 25 ml volumetric flask and slowly add water to the mark. Add 10 drops of aqueous ammonia if the solution ever becomes cloudy. Transfer the solution to a separate clean, dry beaker so that the volumetric flask can be used to prepare another solution. To prepare the second solution, transfer a small portion of the first diluted solution to the 25 ml flask and dilute as appropriate. Repeat this process for the third dilution using a small portion from the second diluted solution.